For today's bell work, determine if the graph shown is a function or not. Write the domain and write the range. Pause the video for 5 minutes to complete the bell work. This graph is a function. I know it's a function because each x only has one y. The domain is x is greater than or equal to -2, and the range is y is greater than or equal to -3. Today we're going to learn how to map a function's input and outputs in order to determine if the function is one-to-one. You will know you understand it when you can determine if a data set is a function and if it's a one-to-one function. To determine if a data set is a one-to-one function, it requires 2 steps. Ask yourself, is it a function? And then is it one-to-one, meaning each x is mapped to its own unique y, meaning no y's repeat. So let's take a look at this first table. I'm going to map my inputs to my outputs. My inputs are 4 and 9. My outputs are 2, -2, 3, and -3. If I map my inputs to their outputs, I'm going to see that this is not a function because my inputs have more than one output. So this one is not a function. So we can stop right there and move on to the next table. Again, I'm going to map my inputs to my outputs. My inputs are -3, -2, and -1. My outputs are 10. My outputs are 10, 9, and 7. When I map them together, -3 maps to 10, -2 maps to 9, -1 maps to 7, but then -2 also maps to +10. So this one again is not a function because one of my inputs has more than one output. So let's look at the last problem. I'm going to map my inputs to my outputs. My inputs are 1, 2, 3, and 4. My outputs are 2, 4, 8, and 16. And when I map them to each other, 1 maps to 2. +2 gives me +4. 3 gives me 8. 4 gives me 16. This one is a function because each input has exactly one output, and it's also one-to-one because no y's repeat. Again, no y's repeat. They are all unique. Now let's check for understanding. Pause the video for 1 minute and in your own words describe what it means for a function to be one-to-one. The correct answer is no y's repeat, or you could have also said each x has a unique y. Now let's try one together. We're going to start by setting up a mapping diagram for each table in order to determine if it is a function. Pause the video for 3 minutes while you set up the mapping diagram for each table. The mapping diagram for the first table looks like this. My list of inputs is -2, -1, 0, 1, and 2. My list of outputs is 11, -4, -5. Now I'm going to map them to each other. 1 goes up and maps -4, 2 goes up and maps to 11. Hopefully you said that this one is a function. Now let's look at the second table. My mapping diagram looks like -2, 0, 1, and 2. But my outputs are different. They look like -8, -1, 0, 1, and +8. I'm going to map them to each other. This one is also a function because each x has exactly one y. Take a minute and think about which of these is 1 to 1. Pause the video for 1 minute while you think. You should have selected Table 2 as the only function on this screen that is 1 to 1. That is because no y's repeat. They're all unique. Over here on the left-hand side, the 11 repeats and the -4 repeats. So this one is not 1 to 1. Take a quick break and do your check for understanding. Match each term to its definition. Pause the video for 1 minute while you complete this task. The definition of 1 to 1 is that each x has a unique y. The definition of a function is just that each x only has one y. Now let's look at a graph. I'm going to determine which of these is a 1 to 1 function. So take a look at the first one. Let me check if it's a function. Yep, so far each x only has one y, so this one is a function. Now I'm going to see if it's 1 to 1, meaning no y's repeat. Well, when I look, I see that this y value, let's say it's a 1, shows up twice. In this y value, let's say it's 2, shows up twice. Same for this y value up here. It shows up twice. This function is not 1 to 1. Let's take a look at the second one. First, let's check if it's a function. Each x only has one y. It is a function. Now let's see if it's 1 to 1. This x value shows up once. This x value once. This function is 1 to 1 because no y's repeat. Now let's check for understanding. Take 2 minutes to determine if the graph is 1 to 1. Hint, check if any of the y's repeat. This graph is not 1 to 1 because some of my y values repeat. They show up more than once. Now you try. You have 5 minutes to determine which of the graphs is a one-to-one function. Pause the video now to complete the task. Let's check our answers. This graph is not a function because my y's, each x has more than one y. This graph is a function, but it is not one-to-one because some of my y's repeat. Graph 4 is a function, but it is not one-to-one because some of my y values repeat. Graph 3 is the only one that is a function and is also one-to-one because no y's repeat. Let's check for understanding real quick. To see if the graph is one-to-one, I am checking if any blank repeat. Take 30 seconds to fill in the blank. The answer should be, we're checking to see if any y's repeat. I would have also accepted output or y values as the answer. In 2 to 3 sentences, summarize what you've learned using the sentence stem, today I learned. Pause the video here for 3 minutes while you reflect. Today we learned that if each input or x has exactly one output or y and no outputs repeat, then it is called a one-to-one function. If you can independently determine if it's one-to-one and a function, you will analyze and explain the errors in determining if a function is one-to-one. If you struggle with the difference between a function and a one-to-one function, you will start by sorting tables and graphs into groups, and then you will move on to the Tier 1 task. If you struggle with creating mapping diagrams, you will match tables to their mapping diagram before moving on to the Tier 2 and Tier 1 task.